Welcome back to another episode of Teaching Math. In this video, I'll teach you everything you need to know about the subject of area. We start with simple rectangles and then quickly focus our attention on more difficult shapes. So, without further ado, let's start the video. Let us start with this rectangle. Area is about how much space is covered. Because the rectangle is 3 centimeters wide and 2 centimeters high, the area of the rectangle is 3 times 2, which is equal to 6 squared centimeters. That means that you could fit 6 of these squares into the rectangle. Besides the area, you can also calculate the perimeter of the rectangle. The perimeter is the total length of all the sides. For this rectangle, the perimeter is equal to 3 plus 2 plus 3 plus 2, which is equal to 10 centimeters. When using grid paper, you can also count the squares the shape is covering. This shape covers 7 whole squares and 2 parts that can be combined into one whole square. So the total area is 8 squared centimeters. Now that we know what area is, let's discuss how to work with its units. Just like the quantity length, the quantity area also uses meter as its base unit. The list is almost the same except for a few changes. First of all, instead of meters and centimeters, we speak of squared meters and squared centimeters. So every unit has a little 2 to denote that. Secondly, every step now has a factor of 100. So to rewrite 5 squared meters into squared decimeters, we need to multiply by 100 for one step. Meaning 5 squared meter is equal to 500 squared decimeter and equal to 50,000 squared centimeters. And 340 squared meter is equal to 3.4 squared decameter. Lastly, squared hectometers and squared decameters have received a secondary name. In the agriculture, 1 squared hectometer is often called a hectare, with the abbreviation HA. The unit squared decameters is also called an R. Although the official symbol for R is an A, it's common practice to just write R as the unit. Just like the units of length, being able to rewrite the unit of area from one to another is an important skill, so make sure you practice it enough. Now that we know the basics of area, let's continue with straight shapes. Sometimes the shape you have to calculate the area of is not a rectangle. Maybe you'll see a shape like this. To calculate the area of such a shape, you need a little bit of magic or a pair of scissors. You see, at our current skill level, we can only calculate the area of a rectangle or a square. And this is certainly not a rectangle. But I could divide the shape into 2 different rectangles. If I draw an auxiliary line here, I now have 2 rectangles, of which I both know the length and width. Rectangle A has an area of 3 times 2, which is equal to 6 squared centimeters. Rectangle B has an area of 8 times 3, which is equal to 24 squared centimeters. This means that the total area of this straight shape is equal to 30 squared centimeters. Let's up the difficulty, shall we? Can you calculate the area of this shape? Pause the video, and when you're ready, keep watching to learn how to solve this problem. When looking at the shape, you might want to try to solve it exactly the same way as before. Meaning you may want to draw an auxiliary line here, and here, maybe over here, and also one over here. Although it may be possible to calculate the area this way, there is a smarter and more efficient way of solving this. You see, you can also draw one auxiliary line over here. That's it. We now already have 3 rectangles. Rectangle A on the right side, rectangle B is the big one over here, and rectangle C acting as a hole. Of rectangle A, we already know that the sides are 1 and 5 centimeters, so the area is 5 squared centimeter. We know rectangle B has a length of 8, but the width is still unknown to us. We can, however, figure this one out without much effort. You see, this horizontal line is 7 centimeters, and this part of rectangle A is equal to 1 centimeter, meaning that the remaining horizontal line is 6 centimeters. Knowing this, we can calculate the area of rectangle B by multiplying 8 and 6, which gives us 48 squared centimeter. Rectangle C, the whole, is 4 by 2, so 8 squared centimeters. To calculate the area of the colored shape, we should add the rectangles A and B and then subtract rectangle C. So 5 plus 48 minus 8, which is equal to 45 squared centimeter. Did you get the same answer? Did you use the same auxiliary lines as I did? Or did you divide the shape into different rectangles? As long as the answer is correct and you write in all intermediate steps, the choice is yours. Now that we understand how to calculate the area of a strange shape, I want to add some algebra to the video. A true master of algebra will never back down from a challenge. Let us calculate both the perimeter and the area of this shape. As you see, instead of numbers, we have several algebraic terms along the sides. To determine the perimeter of the shape, we need to know the total length of all the sides. We do know how long these sides are, but these are still unknown to us. But with some common sense and a little bit of algebra, we can quickly figure out that this side has to be 1x, as the total horizontal length is 6x and we already know 5x. The vertical side over here must be 2y, because the total length should be 5y, meaning that this line is 1y plus the 1y we already have. Now that we know all the sides, calculating the perimeter is an easy task. 6x plus 4y plus 2x plus y plus x plus 2y plus 3x plus 5y. We simplify the expression by adding all the like terms and receive 12x plus 12y as our answer. Now the area of the shape. There are several ways we could cut this shape, but my intuition tells me that this is the easiest way. Doing this will give me 4 rectangles, A, B, C, and D as the whole. Rectangle A is 3x by 5y, meaning the area is equal to 15xy. Rectangle B is x wide and 3y long. I found this one by calculating 4y minus y. So the rectangle's area is 3xy. Rectangle C is 2x by 4y, so 8xy in total. And rectangle D is 2x by y, meaning 2xy is the area of the whole. To calculate the area of the colored shape, add the first 3 rectangles together and then subtract the area of rectangle D, meaning the total area is equal to 15xy plus 3xy plus 8xy minus 2xy, which is equal to 24xy. And with this, we've reached the end of this video. I hope you've learned something new today and that I'll see you in the next video. In paragraph 3, I will teach you how to calculate the area of a triangle. If you forgot what the altitude of a triangle is, I would recommend watching the video of paragraph 7.1 to refresh your memory. See you next time!